this video, we would like to talk about several more complex issues in Bayes' theorem, and in general, the issue of several conditions. So we saw that Bayes' theorem generally is P of H giving E. What is the probability of the hypothesis giving a certain evidence? But in our world, sometimes not only do we have a single bit of evidence, we have multiple bits of evidence. So instead of P of H giving E, I can write P of H giving evidence 1 and evidence 2. These things are very important in autonomous vehicles that receives information from multiple sensors. So the question where the car is located should also contain data or information from one sensor and also data or information from another sensor. How do we approach this problem? P of H giving E1 and E2. So in order to answer this question, we will do two things. First of all, we will give the intuition answer why these things are correct. And afterwards, we will give a mathematical explanation, which is a little bit longer. So the intuition is the following. If I want to calculate Bayes' law while we have several conditions, I can in fact erase one condition and start working. In this example, I will erase E2 and I'm left with E1. But again, I can do it the other way around. I can erase E1 and stay with E2. The probability of H given E1 equals to the probability of E1 given H times the probability of H divided by the probability of E1, Bayes' law. And this is a simple Bayes equation. What does this actually mean giving E1 and E2? This means that I know that evidence 1 occurred, and now someone comes and says, psst, psst, listen, evidence 2 also occurred. What does this mean? Instead of taking P of E1 giving H, I actually need to take P of E1 giving H and E2 as well, because I know it is giving. I know that E2 also occurred. And instead of P of H, I take P of H giving E2. Again, because I know that evidence 2 is given. And of course, instead of taking P of E1, you take P of E1 given E2. And again, of course, we could have switched P of E1 with E2 and we will come to the same conclusion. So this is a phrasing of Bayes' theorem when we are working with two conditions. In order to explain it in a mathematical way, we need to know something that is called the chain rule. The chain rule says the following thing. Let's assume that I have the probability of X, Y, and Z, the joint probability of them. How do I calculate it? According to the chain rule, I can calculate P of X given Y and Z times P, Y, and Z. Okay? And I can take P, Y, and Z and apply once again the chain rule. So P, Y, and Z equals Py given Z times Pz. And the total joint probability P, X, Y, Z equals P of X given Y and Z times P of Y given Z times P of Z. How does it relate to here? Let's take the chain rule exactly as we saw it previously, and what we are interested in finding out is P of H given evidence 1 and evidence 2. Now we know that the conditional probability by definition is this thing, is the joint probability of H evidence 1 and evidence 2 divided by the probability of evidence 1 and evidence 2. This is exactly what we did. This is the definition of conditional probability. I can write it slightly different. Now, if I open the joint probability according to the chain rule, I get the following thing. Now, I can change the position of the element here, and this is what I get. I'm left with exactly the equation that we saw before. So you see, you have two ways to see Bayes' law with multiple conditions. One, the intuitive way, and two, the more mathematical way. Good luck.